Okay, so in this video we are looking to factorize trinomials. Trinomials is an expression with three terms like so, and the method we're using is called the sum and product. Now I really like the sum and product because while it can be a little bit confusing at first, once you get used to it, you can apply it to any trinomial no matter what the situation is. And when we get onto the quote-unquote harder trinomials, it's not going to make a difference. You're still going to be doing the exact same thing. So in this video, we are only looking at things where we've got a squared term at the front on its own. But tomorrow, in the next video, we'll be looking at things like 2x squared and 5x squared and so forth. So let's just jump straight to it and start having a go at this question here. So the first thing you need to do is you need to write out your sum and product table. Now, normally I would just write S and P. For this first question, I would write out the thing fully. So our sum is the middle coefficient. So it's the number in the middle. So that is my sum there. And you include whatever sign is attached to it. My product is the front multiplied with the back. So it's the front number, I'll put in brackets there, the front number multiplied with the back number. Because that x squared is on its own, that means it's a 1x squared. So I'm doing 1 times 8 to give me 8. So that's the first thing I need to do for this question. Let's move that down. The next thing I need to do, I need to think of all the numbers that multiply together to give me 8. So I need to think of all the pairs. So 1 times 8 gives me 8, and my only other pair is 2 times 4. The next thing I need to do is figure out which of these pairs could I add and subtract to give me this positive 6. Well, if I did 2 add 4, that gives me 6. So that is what I am going to use. And again, it has to be strictly either the 2 and the 4 or the 1 and the 8. You can't use a bit of one and a bit of another. So the next thing I'm going to do, I'm going to go back to my original expression and I'm going to basically write it out again, except this time I am splitting the 6x using the numbers I figured out down here. So instead of 6x, I'm going to have plus 2x plus 4x. And then my plus 8 is just the same on the end. The next thing I do is that I need to split it down the middle and make sure that whatever sign is attached to your x coefficient on the right stays on the right hand side of that little squiggly line. Next up I need to do is that I need to common factorize each side. So first, the common factor of x squared plus 2x is x, and then in the bracket will be x plus 2. Then, because that's a plus, this here needs to be a plus. And then the common factor of the highest common factor of this 4x plus 8 is 4. So I'm going to have 4, and then in my bracket, when I do my factorization, will be x plus 2. And what you will notice is that my two brackets here are the exact same. So if you've ended up with the same thing, you know you're on the right track, you're doing something correctly. If it's different, you need to go back, double check, is there something you may have missed? And then the next thing, I now do the last step. So one of my brackets is going to be this x plus 4, so everything that's on the outside. And my second bracket is just one of these x plus 2's. And that's it. I have managed to factorize that expression. Now, the benefit of factorizing is that you can double check by expanding your answer out. And we're going to do that in a second. because you will notice something that occurs when I do my expansion. So I'm just going to split it up. Multiply it out. And then collect my like terms together. And yep, I've gotten back to the beginning. That's exactly what I had originally. And what essentially happens is that this method is the reverse of our expanding method that we do. So that's another reason why I quite like the sum product, because here was my start, here is my end of expansion. Then I've got that 2x plus 4, and here I have that 2x plus 4. Then I have my x and the plus 4 on the outside, and the x plus 2 in the brackets. And there's my start and my end. So that's another reason why I quite like this sum product method. So let's go on to the next question then. So, writing out my sum and my product table. So my sum is that -7. My product, because that's going to be a 1 at the front, so 1 times 12. And then things that multiply together to give me 12. 1 times 12, 2 times 6, and 3 times 4. So we need to add or subtract one of these pairs to give me -7. Well, if I did 3 add 4, that would give me a +7. So if I just take the negative of all those and do -3 take away 4, that would give me that -7. So that is what I am working with. So back to my original one, I've got m squared, and I'm going to have take away 3m, take away 4m. Actually, let's do those in, didn't mean to do it that big. Let's do that in the lighter green. So remember, that's when I split it up using the two numbers I found earlier. Plus 12, splitting it down the middle. Common factor on this first half. Highest one is m, and that'll be m minus 3. Because that's a minus here, I need a minus next. Highest common factor here is 4. Then I'm going to have m. And then remember, this is -4 times something to give me a +12. So because I'm going from a negative to a positive, that also needs to be negative because I need that double negative happening. So -3. And there we can see my two brackets are the exact same. And then my one of mine is going to be that m minus 4. And my other bracket will be this m minus 3. Okay, next one. So again, setting up my sum and my product table. So that's going to be a 1 there, that's going to be a 1 there. My sum is +1. My product is -20. And I'm not going to worry too much about the negatives right now. So I'm just going to think of things that multiply together to give me 20 there. So 1 times 20 will 2 times 10, and why am I writing 3? Don't know. 4 times 5. So something that then gives me this +1. If I do 5 take away 4, that would give me that 1. And the other reason why that works is that if I think about these numbers individually, if I did 5 times that -4, that would give me that -20 that I needed in the product. So that's another reason why it works. So you can always do that to double check to make sure that you're correct on the negative or the positive side of things. So Going back up to the top, so that's going to be b squared plus 5b minus 4b minus 20. Split it down the middle. Highest common factor on this side is that b. Inside is going to be b plus 5. Because that's a minus there, I'm going to have a minus here. Highest common factor there is 4. I'm going to b. Because that's a negative and that is still a negative, that means this needs to be a positive. So it's going to be a positive 5. And there, my brackets are the same, so I know I'm on the right track. And then outside I've got b minus 4, so that's one of my brackets. And my other bracket is that b plus 5. Okay, next one. So here I've got f squared minus 7f minus 30. So setting up my sum and product. So my sum is at negative 7. My product multiplying the front number with the back number is negative 30. Things that multiply together to give me 30. 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Well, to get negative 7, that can be done by doing 3 take away 10, which will give me that negative 7. So that is what I am working with. And again, if I needed to check, if I did 3 times negative 10, that does give me negative 30, so that works. Okay, so I'm going to have f squared plus 3f minus 10f minus 30, splitting it down the middle. Highest common factor on the first half is going to be f, and f plus 3. Because that's a minus next, I need a minus there. Highest common factor of the 10f minus 30 is 10. That'll be f plus 3. And then grouping it together, I've got f minus 10 on the outside. And then I've got f plus 3 as one of my other brackets. Okay, so that was us covering over all the difference of plus and minus. I've got one more question to go through, and that's this one here. So here I've got x squared minus 16. Now, I can square root the x squared, I can square root the 16, I've got that minus. That tells me this is a difference of 2 squares. So normally there is that shortcut method to help us figure it out. However, sometimes you can forget that in the moment, or you might not pick up that you can square root everything. So we're going to apply the sum and product method to this question here. So we can still use this method even on a difference of 2 squares if we suddenly struggle to remember the trick. So setting up my table. Now, for my sum, there isn't anything there. And if we think about it, what could be in the middle there is plus 0x. Because 0 times something means there's nothing. So that means my sum is just 0. So it still kind of exists, but we don't actually require it. Then my product, same as before, multiplying the front and the back together, is minus 16. Things that multiply together to give me 16. 1 times 16, 2 times 8, and 4 times 4. And to make 0, I do 4 take away 4, which gives me 0. So that's now going to be x squared plus 4x minus 4x minus 16. Splitting it down the middle, factorising the first half will be x plus 4. Going to use that minus sign, factorising the second half is going to be x. That'll to be x plus 4. And then on the outside, I've got that x minus 4. And inside, I've got that x plus 4. And there I have that question factorised. So I can use this method for a difference of two squares if I forget the trick as well. Let me know if there are any issues, and good luck with the work.